Hello, welcome. Today I would like to create the 3D model of a static mixer in Salome software. We have only a few open source CAD and meshing softwares like Salome and Gmesh or OpenFOAM's Snappy Hex Mesh and CF Mesh, etc. But for the CAD, I forgot. We also have FreeCAD. But for the CAD, I find Salome to be very effective, especially with the later developed Shaper module. So, which is very powerful. It's like I've been an ANSYS workbench user for a long time, and I've always wished like I should have something like Design Modeler, and the Shaper has so many features similar to Design Modeler. So let's get started. And first we have the drawing for the static mixer, and actually this drawing is from Mr. Joel Guaro from Wolf Dynamics OpenFOAM training class, and he open sourced everything in his training class, so I used and now I give him credit. Okay, so this is the static mixer. It's simple cylindrical shape with two inlets and one outlet at the bottom. So let's get started and open Salome. Okay. I don't know how should I pronounce this software. It's Salome or Salome, but I will call it Salome. Anyway, it has like a few modules: shaper, geometry, and mesh, and the others are Paravis, which will open up the ParaView edit plugin, and we also have some YACS which will automate, which can be used to automate your simulation process. Actually, honestly, I don't know much about these. I only know the shaper, geometry, and mesh. Actually, in previous like version 6 of Salome, we didn't have this shaper. We only have geometry, which is not as efficient and effective as shaper, especially for parametric modeling workflow. And so we go ahead and click the shaper, and this is the shaper module, and these are the toolbars for creating a sketch and extruding, rotating the sketch to create 3D models, and to some features like fuse and cut and fillet to edit and combine the 3D models. Okay, so the first thing we need to do is click the part. We need to create a new part, and for this new part we can create a sketch. So we will choose the X subplane, which is this plane, and we can click this set plane view to have a good view. Okay, so let me look at the drawing. So it's we will create this sorry we will create this sketch, and we will revolve around this as the axis. So this is first okay. Let's create it first, and here we can create a line, and we can see whether the line is horizontal or not by looking at here. So I'll just click the escape, and first I will want to give some dimensions for. So this is 500 millimeters, so 5.5 meters. So why should I add a dimension before doing anything? Because I want to know the size of this my shape. So I can go ahead, and now I have the idea of how my shape should look like. Because otherwise when I add dimensions after creating the whole draft, I need to manage more. Okay, by giving one dimension, I can easily manage the whole. I can see the big picture, what size the big picture look like, and I can draw it. So this height is like 1 meter, so it's around here. And so in Salome, if we want to move like pen, we need to click press the control and drag. Okay, and so this is the slope, and then this is another vertical line, and a horizontal line, and okay, here. Okay, so we add dimensions for other lines. So this is, oops, okay, this is one, I believe, right? No, it's 4, so the radius should be 2. Okay, so if we want to change the dimensions, it's easy, just double click it and edit it. Anyway, we can first assign the dimensions here. It's 1 here, it's also 1, and here I think it's also 1, right? Now we can see the our sketch is in green, which shows all the constraints are already resolved. So we can just revolve it or do whatever we want. Anyway, I need to change the diameter to be of the mixer to 4 meters. So this is 2. Okay, it should be like this, right? And if we are sure about everything, we can click this apply button, and here we go. So we have the sketch, and all we need to do is to revolve, which is this button, revolution, and click it, and we need to choose this faces. And actually it's we need to choose the face. This can be our sketch can be regarded either as a edge or a face. So we should assign as a face. So we assign this and choose our sketch. Okay, we have base object is our sketch, and this is the vector around which it will be revolved, which is this line. Okay, now click apply, and here we go. We have our the main body of the mixer, but we don't have the inlets and outlets yet. So I want to add the inlets and outlets. So, well, the idea is to create these circles and just extrude them. So I would need another sketch. So create sketch, and the plane should be here. Okay, and create a circle. Okay, and we give the dimensions for this circle here. It was like one diameter. One is 1 meter, so I will give 0.5 meters, and the distance from the rim is 1 meter too. So it's this one is the distance dimension. So I click. It will it can be used to assign the distance between a line and a point, especially a line and a point. So first click the point and then the line. Okay, so it's 1 meters, and from the lower edge it's another 1 meters. So I'll give it vertical dimensions. Okay, this was a vertical distance. Okay, this is 1 meters. Oops. Okay, my the height is wrong. I was wrong. It's 2 meters, not 1 meter. So I will need to change. Oops. Okay. I need to change. So first I will create the dimension to be 1 and click apply. So it will be applied, and one of the problems I have is okay, sorry, never mind. So I need to change the sketch 1 2. So here we finish this sketch by clicking the apply button, and we need to edit sketch 1 because this dimension is 2 meters, not 1 meters. So apply. So here we have the first inlet cylinder. So we will need another cylinder for outlet, so another inlet. So we need to create another sketch, and okay, so the plane is here. Okay, and this time we will create a mirror copy for this object, and we will need to assign a mirror line about which this sketch will be mirrored. So I will choose this. Here we go, and click apply. So now we have 3 sketches, which sketch 1 was used to create the revolution. The results are here. which are 3D shapes, and okay, the left one should go into the positive y direction, so this guy should go into the positive direction. So I will extrude this. Here is the extrusion, and click the inside the circle as a, because we want to assign it as a surface. So in negative y direction it's 0, and in positive direction y direction it's like, oops, I forgot, it's 3000. Okay, so 3 meters. Okay, good. And we need to extrude another one in negative y direction, 3 meters too. Okay, now we have 3 objects, and we need to combine these, and in features we have fuse. So click the fuse and then shift click all the objects. In here we have 3 objects, and we check the remove intersection edges. So, and click apply. Now we have our geometry. So we have the inlets, 2 inlets and 1 outlet, and the rest are the walls. So okay, let's go ahead and save it. Save the document, and okay, OpenFOAM. Okay, okay. Now we need to create the mesh for the this geometry. So first we need to create the inlets and outlets and wall patches, which will be done in geometry module. So we need to create the geometry object which will be used in geometry module. So here in the features we need to click this export to geom, and the geometry object which will be used in the geometry module will be created. So we leave the shaper and move on to geometry. Okay, sorry, I need to hide this before moving on to geometry, because these are a bit confusing. Now this is the geometry object created from in shaper and exported to geometry. So we can create the inlets and outlets here in the menu, new entity, and group, create group. So, and the main shape is fuse 1 1, which is this object, and we need to choose this to instruct our group is a surface. So face. Okay, I will give this an inlet 1, so it's, let's name it. Okay, click it and add, and this is the number of the face to be assigned this name, which is inlet 1, and apply, and inlet 2 will be applied to here, and outlet will be applied to this guy. Okay, the rest will be walls. Oops. So shift click all the walls. Okay, I'm confused again. Now I remember. Okay, this is a bit confusing, but don't worry. If we left some wall, some face, we can see it later. So we don't have any more patches to create, so apply and close. Well, so here we have inlet 1, inlet 2, outlet, and walls. So okay, as I mentioned, I missed one face, so right click it and edit group. So the selected, you can easily see the selected faces, and you can add this and add apply and close. Now we have the walls. So we have all the objects and the walls. So now we can create the mesh. Okay, so let's move on to the mesh and module. Okay, this is the mesh module, and first we will open the, we can make it visible, our geometry, and this button, which is which is fit all, it can be used to see our object easily. So this is our geometry, and we need to create a mesh. So in the click our geometry, which is fuse 1 1, and click mesh, create mesh. And here we have name mesh 1 and geometry is fuse 1 1, and mesh type is any. We can instruct Salome to have triangular, quadrilateral, or like tetrahedral. For 2D, triangular and quadrilateral. For 3D, heads and heads. So I will use tetrahedral. So with together with prisms. First, we need to choose the algorithm. We have a few ones: a NetGen 1D, 2D, 3D, and NetGen 3D. And these MG guys are the commercial measures. So we don't have the license, so we can not use it. So the only things we have are the NetGen and GMSH and the body fitting. So I will use this one. And this hypothesis means we can give the parameters of the size of our mesh, which is the maximum size should be 0.8, so it's like 0.5. This is just more of an iterative process, so we need to go try and error until we have a nice mesh. So the maximum size is 0.05. Okay, fineness, I prefer fine because the growth rate is smaller. Okay, anyway, first start with the moderate. Okay, and apply and close. So let's try and create our first mesh. So in this object browser, we have the mesh, and we need to click this arrow, and we have this is our mesh. So we need to click our mesh, and this one, compute, or we can also click from the menu, mesh, compute, and it will generate the mesh. Okay, so this is our first mesh, and let's see the inside. The outside seems not so bad for like very default settings. So let's look at the inside. First, right click to the on the main window and clipping. Okay, and then we can choose new absolute. So now we have our plane. through which this mesh will be divided. So the directions I want while playing. So this is the y direction. So all we need is to make dx and dz to 0 and apply. Okay, now we have, oops, it's too big, right? Okay, yeah, this is how it should look like. So we have two things to do. We need to refine the mesh to capture the necessary flow features, and another thing is to add an boundary layer mesh, prism layer. So we will try to add a prism layer. So this is the additional hypothesis, and click this gear button and viscous layer. So this is the setting for the viscous layers and our boundary layer mesh. And the tricky part is the things we can control are only these three factors. We can control the total thickness, number of layers, and stretch factor. So you may think it's enough to create a nice inflation layer, but the problem is this total thickness we define is absolute, and it will be used on all the faces, all the walls. Even if the wall is small, it will create a big, thick viscous layer. So let's go ahead and try 0.01. 0.1. Can we want at least 3 layers, and stretch factors is 1.2. This is like the upper limit for the stretch factors, and we can look at these later. And we need to instruct the faces to which the viscous layers will be applied. So these should be the walls. So we need to we can choose faces with layers or without layers. It means we can instruct which layers to add the viscous layers and which face not to add. So we will go with the layers, walls, and click on this object browser, and in the geometry click on the walls and then add. So these are the face numbers to be used in creation of the viscous layers. So click OK, apply, close. Now the mesh is gone because we need to create a new one. So compute to remesh. Let's see the mesh. So this is the problem I was talking about. Here the inside the cells are very big, and the boundary layer mesh, the prisms are too thin compared to these. So we have a problem of when calculating the gradients. So the trick is to use a new surface mesh to create the cells nearest to the walls, to make the cells nearest to the walls small. Okay. So first we can try and adjust the our mesh cell size parameters. So click it, and here we can reduce the maximum size to be 0.2, 0.1 maybe. Okay, let's try and remesh. Okay, it takes quite long, it seems. Okay, this is a lot of elements here. We have 186,000 volumes, which in my opinion is a bit too much for this. Well, anyway, the boundary layer mesh seems much better, and the size difference is much better. The problem is we have a lot of unnecessary cells around here, so I don't want them, and I will try another approach. So the idea is to make the cells closest to the wall, I mean except the boundary layer, or these cells small, meanwhile the rest will be made coarse. So I will try to, okay, I will create a reset the mesh maximum mesh size to 0.5, probably, which is a bit too coarse. Anyway, this is not for validation, just for starting, so it's okay. So what should we do now? Right click our mesh, and we want to create a sub mesh. Create a sub mesh. So the mesh is mesh 1, and geometry is walls. Okay, so this sub mesh will be created so that the cells closest to the walls will be smaller than our main mesh. So we choose NetGen 1D 2D. It means 1D 2D 3D means the mesh generator will go up to 3D, and the volume mesh, and NetGen 1D 2D means it will go up to the surface mesh. So we adjust the hypothesis NetGen 2D parameters. Again, this is the size, so we keep it small. Okay, around like this, and we want to see our submesh first. So click the arrow near the submesh and compute. Okay, so this is our submesh. Maybe it's not fine enough, but let's see. So this is our main mesh. So yeah, it's a bit better. So all we need is to decrease the size a bit, and to both the main mesh and to the 0.1. Okay, sub mesh. Okay, let's go ahead and compute. Well, it will create a lot of cells, I think. Maybe we need to do it again. Let's see. Okay, this is yeah, this seems really good to me. Okay, the cell count is, you can check the cell count here in this 1, 2, 3 button, and we have like almost 100,000 elements, and I'm fine with it. So okay, and we also already have the patches, and now all we need to do is export the mesh. Just click the mesh, right click the mesh and export, and choose the UNV file, and we want to make sure our mesh is renumbered and give whatever name we want. Static, okay, mesh 1 is okay. Okay, let's go ahead and check. This is our UNV is our mesh, and now we close save the document, and we can close Salome. So I prepared the required OpenFOAM files, so we can do some creating a mesh. Static mixer 2. Okay. Now we clear up, and okay, so the command is ideas unv to form, and the input is the mesh file mesh1.unv, and OpenFOAM will convert the mesh, so we can check mesh. Okay, well, we have a bit of too much non-orthogonality, which is greater than 70 degrees. OpenFOAM is a bit choosy in terms of non-orthogonality, but the mesh maximum screwness is okay, so I assume this mesh is okay, so we can run the simulation from now. And we need to edit the boundary, and because the mesh converter we used before try to change all the faces to type patch. We have walls, so we change walls, and we can run it. I will cover the details of OpenFOAM settings later. So like, okay, we have some problems. Okay, patch type for patch walls must be walls. Okay, I was wrong. A wall, not S. Okay. Here. Okay. The simulation runs, but it's not. We have some problems, so I will later try to adjust everything and cover it in another video. Thanks for watching.